Okay, now a rhombus is kind of like a cousin to the square because all the sides are equal and it's a parallelogram, but all the angles might not be 90 degrees. So it's kind of like a square that's been a little bit bullied around. So here's a beat-up square, which is also known as a rhombus. I'm just kidding, of course. Really, rhombuses aren't picked on. Rhombuses are very nice, and they're just parallelograms where every single side has the same length. So don't send me an email. It's all good. I like some of my best favorite shapes are rhombi. All right, here we go. So here we're told this is a rhombus, so we have that information at our disposal. A, B, C, D is a rhombus. And then we're told sort of this sort of algebraic stuff that this length is 4x and this length here is 5x minus 3. And our mission is to find the length of a CD. So how long is that? Well, this seems like a tricky question because it's like, wow, we don't have any information at all. But we do. We know it's a rhombus. And so if it's a rhombus, we know that every side actually has the same length as any other side. In particular, this side has the same length as that side. So if this has length 4x and this has length 5x minus 3, then I know those two numbers have to be equal. So I have 4x equals 5x minus 3. And now we can solve for x. And so if we solve for x, I don't know how you would do that. I would actually subtract 4 from both sides, 4x from both sides. And so I have 0 equals 5x, and I subtract away 4x's. I'm left with 1x minus 3. And then I add 3 to both sides, and I see that 3 is equal to x. So x equals 3. Now we might do our little happy dance. We got the answer. X equals 3. Let's go home. No! That's x. We want this length right here. How am I going to possibly find that? Well, remember, since I know it's a rhombus, every single side has the same length as any other side, so I'll just find the length of this side. Plug in x equals 3 into here. 4 times 3 is 12. This has length 12. Therefore, since it's a rhombus, this has length 12 as well. And so the answer is not 3, but in fact, 12. Look how we're using all the properties of a rhombus in order to even solve a question that's both at once geometric and algebraic. Cool. Let's try another one together. So here, I'm given another rhombus, ABCD, and the question is, what is the measure of angle ADB? So we want to find this little teeny angle right here, knowing that we have a rhombus. Now, we know all the really weird algebraic stuff, like the measure of this angle here is 11y plus 2 degrees, and the measure of this little angle here, I guess it's CAD, right there, that's 7y plus 4 degrees. But that's all we know, together with the fact that it's a rhombus. Well, it looks like we don't have enough information to even answer this question, but this is where we get to use a really cool fact about a rhombus, which is that the diagonals actually meet and form angles of 90 degrees. So in fact, this is so cool. This angle right here is a right angle. So that's 90 degrees. And that's going to allow us to break into this question. Because since I know this is 90 degrees, I can now solve this for y. Once I have the value for y, I can insert it into here, and all of a sudden I'll start to get angles bubbling out along the interior of this rhombus. Let's try it together, shall we? So the first thing we know is that this angle measure, 11y plus 2, equals 90 degrees. So if I subtract 2 from both sides, I see 11y equals 88, and that tells me, if I divide both sides by 11, that y equals 8. Now, you might say, oh, y equals 8, we're done, homework is over, let's watch Math TV. No, not yet, because that's just y. We want to find this angle here. So this is an intermediate step to get us closer to y. So we've taken a step toward y. That's awesome. Toward this angle. So if y equals 8, then I can come up here and plug that value in for y. It's the same y. I now know it's 8, and I can figure out what that angle is. So 7 times 8 is 56, plus 4 is 60. So that angle right there is 60 degrees, has a 60-degree measure. And now, I'm going to use another property of the rhombus, which is that, in fact, the diagonal bisects the interior angle. So therefore, if this is 60 degrees, that means that this angle here is also 60 degrees. So this angle here is congruent to this angle right here, and it's also 60 degrees. So this entire angle, angle BAD, is what? Well, it has a measure of 60 plus 60, which is 120 degrees. So we have a 120 degree angle up here. It's a really big angle up there. But remember, in a rhombus, this side is parallel to the opposite side. So these are parallel lines. This is a transversal. So I know that this angle and this angle right here, this whole angle, in fact, are going to be supplementary. This is 120 degrees, which means if I take 180 and subtract 120, this entire angle here must be 60 degrees. So this whole thing is 60. Does that mean my answer is 60 degrees? No, but we're almost there. We're halfway there because we know that this diagonal will cut this angle in half. It bisects it. So if the whole thing is 60, then this half of it must be 30 degrees. And we finally have arrived at the answer. The answer is the measure of angle ADB equals 30 degrees. And that is the official answer. And now it's time for Math TV.